This is very important numerical. So let us look at the statement first. There is a plane inclined to horizontal by an angle beta. A ball is projected making an angle theta with horizontal. Then find out expression for range on inclined plane. Find conditions for maximum range and Rmax. So there is a plane inclined to horizontal. Now first of all try to make the figure. This is horizontal and a plane is inclined to horizontal at an angle beta. Okay, this is angle beta. A ball is projected making an angle theta with horizontal, and a ball is projected making an angle theta with this horizontal, and obviously the ball will fall at A point instead of B. So it is making an angle theta with the horizontal. This angle is theta. Find out the expression for range. We have to find the range. What is range? Range is the horizontal distance traveled by the projectile, and here the range is OA. We have to find OA and find the conditions for. First of all, we are going to find this range. So if we compare this with the simple projectile, that is ordinary projectile, angular projectile, we have to, if we want to find range, then what is the formula for this horizontal distance? We are using the three equations of motion. Here we have the options of using v square minus u square equals to 2as and s equals to ut plus half at square. We are going to neglect v square minus u square equals to 2as because it is not possible to find the final velocity along this direction. So we are going to find use s equals to ut plus half at square, and in this formula we are just going to use s equals to ut because in horizontal direction the horizontal component of the velocity remains constant in case of the projectile motion and there is no acceleration. Now, so to find the range, first we have to find the velocity in that direction. The velocity should be in this direction OA. And what will be the velocity? This is u and the component will be the angle this. What will be this angle? This angle. This angle will be theta minus beta. So the velocity is here, horizontal velocity along horizontal velocity along OA equals to u cos theta minus beta. Now the second is t. How to find t? So if we compare for finding t, in case of this angular projectile, what is the method we use to find t? We always take g which acts at 90 degree with this horizontal, and we always consider maximum displacement is 0 because when the projectile moves in the upward direction, it covers this much distance and then it again falls down and the net displacement is 0. And obviously we are going to consider the vertical motion is responsible for this flight. So g is at 90 degree, here vertical displacement is 0, a equals to g, and we have another component u, and t we will find. This is the case of angular projectile. In our case, if we compare these two, here g is making angle 90 degree with the horizontal, and Can we take the whole value of G along OA? No. We will take the component. How to find that component? We just suppose a direction which is perpendicular to OA, so that we can find our T. So here G is perpendicular to this, and in case of this, G is this angle, as this plane is making angle beta with the horizontal, so the angle between this OP and OA is 90 degree. So angle between this G is angle beta with this OP. So this component is going to act component of G will act on this projectile or the ball. So we have vertical displacement 0, G is there, and which component of U we are going to take? So the angle between U and this OP, this angle. How to find this angle? This is 90 and this is theta minus beta, and this angle will be 90 minus theta minus beta. And so angle is, we are going to consider this. This is the horizontal component, so the component we are going to use, component of U is equals to U cos 90 minus theta minus beta. So this is U sin theta minus beta. Now SV equals to 0. So if we apply S equals to UT plus half GT square, S is 0, so SV is there, U sin theta minus beta into T plus half minus G cos beta into T square. Just take a T common and T equals to 0. T will cancel out, and this is now, if we solve, we will get T equals to 2U sin theta minus beta upon G cos beta. This is the value of T. Now for range, here we know range equals to U into T. What is the U? U will be, we will consider which U will we are going to consider. This is this one. So what is the formula for range? For expression for range will be U into T. U value of U is U cos theta minus beta into, what is T here? This is T, or just U cos theta minus beta into 2U sin theta minus beta upon G cos beta. We are going to simplify this. U square sin 2 theta minus beta upon G cos beta. So if we consider range in this case, the formula for range in this case equals to U square sin 2 theta upon G. Only the difference is because there is angle beta, so here comes beta, and it is double the angle made by the projectile with the horizontal. The sine is 2 theta here. Here the angle is made, angle with the horizontal is theta minus beta, so it is twice. So format is same. So now the next is a range for inclined plane is there. This is range. Okay, this is R. Now condition for R max. This is simple. Just we know the maximum value for a sine theta is 1. So we put sine 2 theta minus beta equals to 1, 2 theta minus beta equals to sine 90. So if we solve this, theta minus beta comes out to be 45 degree. So R max, what will be the R max? R max in this case. In this case, the R max will be u 2 into 2 theta minus beta becomes 1 u square upon g cos beta. This is the R max. We have find the maximum range. Condition for maximum range is there, this, and R max is there. If we compare R max for with this, in this case, here R max will be u square upon g. You can compare, the format is same. So this is the question. This is very important question.